On April 10, 2026, the Orion spacecraft splashed down in the Pacific Ocean. 4 astronauts walked off the recovery helicopter under their own power. The parachutes had deployed in sequence. The trajectory had been almost perfect. NASA's mission commentator Rob Navias called it a perfect bullseye splashdown. Associate Administrator Amit Kshatriya called it an incredible test of an incredible machine and a gift to the world. Every news outlet on Earth covered the celebration. And underneath all of that, a quieter truth was being buried. One the people running the program know, but that no one in a position of authority is willing to say out loud. Artemis II succeeded as a crew return mission. It failed as a test flight. Those are not the same thing. The distinction matters more than anyone wants to admit, because the entire purpose of Artemis II was not to bring 4 people to the moon and back. That was the minimum requirement. The actual mission was to verify that the hardware is ready to carry the next crew to the lunar surface, to prove that the systems work as designed, and to close out the engineering questions left open by Artemis I in 2022. By that standard, the one that NASA itself set when the mission was conceived, Artemis II came home with a long list of failures that the celebration coverage has been carefully sidestepping. Start with the heat shield because it's the one that matters most. The entire reason Artemis II flew when it did, with the trajectory it used, is that engineers were terrified of what happened to Artemis I. When the uncrewed Artemis I capsule returned from the moon in November 2022, its heat shield came back with more than 100 cracks and large divots where the avcoat material had failed and flaked away. Any one of those damage points could have burned through to the aluminum structure beneath and killed a hypothetical crew. NASA's investigation determined that the ablative material was trapping hot gases beneath the surface, which built up pressure and caused the avcoat to crack in ways no one had predicted. The agency had 2 choices: redesign the heat shield completely, which would have delayed the program by 2 years or more, or modify the re-entry trajectory to reduce the thermal load on the existing shield and hope it would behave better. They chose the second option. Artemis II flew with the same heat shield design and a modified re-entry trajectory, a steeper angle, shorter time in the peak heating zone, and less margin for weather at the splashdown site. Former NASA engineer Charles Camarda, a heat shield expert who served on the first space shuttle crew to fly after Columbia, called the decision playing Russian roulette. Former astronaut Danny Olivas, who served on the independent review team that investigated the Artemis I damage, told CNN in January that this is a deviant heat shield and not the heat shield NASA would want to give its astronauts. Artemis II flew anyway, and according to NASA's own post-splashdown press conference, the heat shield came back with divots again. Howard Hu, the Orion program manager, confirmed it. Divers were in the water within minutes of splashdown, photographing the damage. Aircraft tracked the capsule as it descended to capture thermal data in real time. The capsule is now being transported to Kennedy Space Center for detailed scans, and the conclusion is already clear, even before the final analysis is done. The modified trajectory reduced the damage, but did not eliminate it. The same failure mode that occurred on Artemis I in 2022 occurred again on Artemis II in 2026, 4 years later, after 4 years of engineering work that was supposed to solve the problem. That is not a pass. That is not a successful test. That is a second data point confirming the first one. NASA has announced that Artemis III will fly with a redesigned avcoat formulation, one with different porosity intended to let the trapped gases escape. That admission, the admission that the current design needs to be changed, is the clearest possible statement that Artemis II's heat shield is not ready to fly again. The new formulation has never flown. It will be tested for the first time on a mission that is supposed to carry crew. That is the definition of an unresolved problem. And Artemis II, which was supposed to resolve it, did not. Then there is the service module. During the mission, NASA detected a helium leak in the oxidizer pressurization system of the European service module. The agency knew about the leak before the flight. They had seen it during ground tests. But the leak rate in space was, Kshatriya said, an order of magnitude higher than on the ground, 10 times worse. The leak did not threaten the crew because Orion's final trajectory correction burns used residual tank pressure, a technique called blowdown mode, which does not require active helium pressurization. But on Artemis IV, which is the mission that will actually land humans on the moon, the service module has to perform a lunar orbit insertion burn. That burn requires full pressurization, and the current valve system as flown on Artemis II cannot deliver it reliably. Kshatriya said that directly at the post-splashdown press conference. The valve system will require an extensive redesign before Artemis IV. That is an engineering change to a system that was supposed to be proven by this flight. Artemis II was the demonstration that the service module works. It did not. It worked well enough to get this crew home on a flyby mission that did not require a lunar orbit insertion burn, but it did not demonstrate readiness for the mission that actually matters. The data gathered from the leak will inform the redesign. That is a useful outcome. It is not the outcome the mission was designed to produce. The toilet failed. Not once, but at least twice. During the outbound leg, ice formed in the wastewater vent line, blocking the system. The crew had to execute an in-space maneuver that repositioned the spacecraft to thaw the vent tube. The fan inside the system jammed, and the crew had to free it manually. During the after-splashdown briefing, NASA Chief Jared Isaacman said that nailing this capability is one that we need to certainly work on. This is not a joke. A toilet that fails in lunar orbit during a 7-day surface stay is not a minor inconvenience. It is a potential mission abort. And the one NASA just flew in the most controlled and monitored conditions possible, with the closest possible support from Houston, failed twice. The satellite phone system glitched during recovery. The capsule's communications had trouble powering down properly after splashdown, delaying the approach of the recovery boats. A small latching current limiter failed, the same type of failure that was observed repeatedly on Artemis I in 2022. That failure mode, 4 years after it was first documented, has still not been eliminated. These are not individual anomalies. These are a pattern. Subsystems with known issues flew again, carrying the same issues and producing the same failures on the program's second flight. And then there is the structural issue that nobody wants to name. Artemis II was sold to the public as the dress rehearsal for the lunar landing. The press coverage treated it as such. But somewhere between the mission being assigned and the mission flying, the definition of success quietly changed. The original framing was that Artemis II will prove the hardware. The actual framing, as articulated by NASA's own post-splashdown language, is that Artemis II brought the crew home and gave us data to improve the hardware for future missions. That is a fundamentally different claim. One is a pass, the other is a deferral. And the only reason it does not look like a failure is that NASA set the bar low enough to walk over it. Compare this to Apollo. When Apollo 8 flew around the moon in December 1968, it tested the Saturn V and the command module in deep space for the first time with crew. Apollo 9 in March 1969 tested the lunar module in Earth orbit. Apollo 10 in May 1969 did a full dress rehearsal in lunar orbit, including descending to within 50,000 feet of the surface in the lunar module. By the time Apollo 11 landed in July 1969, every piece of hardware had been tested in its actual flight configuration, in the actual environment where it would operate. That is what a test flight program looks like when the definition of success is tied to engineering readiness. Artemis II was supposed to serve that function for the Artemis program. Instead, it flew with a heat shield known to be flawed, a service module with a leak NASA had been tracking on the ground, a toilet that had never been tested in deep space, and subsystems carrying failures inherited from Artemis I 4 years earlier. The mission succeeded in the sense that nobody died. It failed in the sense that it did not demonstrate that the hardware is ready for the next mission. That fact is documented in NASA's own post-splashdown press conference, in the admission that the heat shield formulation needs to change, the valve system needs an extensive redesign, the toilet needs work, and the program has a tight turnaround for Artemis II. None of this is a scandal. Spaceflight is hard. Test flights reveal problems. That is literally what they are for. What is scandalous is the refusal to say this clearly in public. The gap between the internal engineering assessment of Artemis II and the public narrative about Artemis II is enormous, and that gap is being maintained deliberately. Because if you say out loud that the mission did not achieve its engineering goals, you invite the question of what that means for Artemis III, which is scheduled to fly next year carrying crew. You invite the question of whether the redesigned heat shield will be ready. You invite the question of whether the valve system can be fixed in time. You invite the question of whether the toilet can be made reliable. You invite the question of whether the Starship HLS will be refueled and ready at the same time. You invite the question of whether the landing, now slipped to Artemis IV in 2028, is going to slip again. Those are uncomfortable questions. They are also the correct questions. The reason nobody in a position of authority is answering them is that the answers would undermine the celebration that NASA needs politically to keep the program funded through another budget cycle. Artemis II was as much a political mission as an engineering one. The political mission succeeded. The engineering mission did not. In 5 years, when people look back on this program, the metric that will matter is not whether the crew came home. It is whether the program landed on the moon before the decade was out, which was the stated goal. On current evidence based on the hardware that came home in charred pieces and the hardware that still does not exist, that outcome is more uncertain than anyone is willing to admit. Artemis II succeeded. Artemis II failed. Both are true. Which one matters depends on what you think this program was supposed to accomplish. If the goal was to bring 4 people to the moon and back alive, the mission was a triumph. If the goal was to prove that America is ready to put boots on the lunar surface, the mission was a warning. The celebration coverage is telling you the first story. The engineering coverage, if you know where to look, is telling you the second. One of those stories is going to turn out to be right. We will know which one in the next 3 years. If you want to keep exploring what the universe is really doing, subscribe. I'll see you in the next one.